Okay, welcome back. This is going to be the fifth video here in the S1 equation series. So far we've discussed the three variables to the right side of the equation, and those being refusal speed, maximum braking speed, and rotation speed. We've discussed that S1 has to be less than or equal to those three variables. In this video, we're going to introduce the first variable on the left side being VMCG, or ground minimum control speed. Before we get into the ground minimum control speed definition and then how it applies to our takeoff, let's discuss a few topics here that we kind of mentioned earlier, but I just want to make sure that everybody's on the same page. So earlier we talked about the situation if we wanted to abort, right? How would we actually do that? Well, to control the aircraft via an abort, we would bring the good throttles, or both throttles, to idle, apply brakes, and speed brakes if necessary, if they're available to us, which they normally should be. In another case, this is how we're going to control the aircraft via an abort scenario. Now, if we need to continue the takeoff, we would control the aircraft using our rudder, spoilers, and elevator. Rudder keeping the nose on centerline, spoilers keeping our wings level, and the elevator to help maintain our attitude level. And once we reach that safe rotation speed, we use the elevator to take the aircraft airborne. So again, if we want to control the aircraft via an abort, we bring the throttles to idle, use the brakes and speed brakes. If we want to continue the takeoff, we'd use rudder, spoilers, and elevator. Now, to get back to ground minimum control speed, what is it? Ground minimum control speed, 88 knots, is the minimum controllable speed during the takeoff run at which, when an engine is failed, it is possible to maintain directional control using only primary aerodynamic controls without deviating more than 25 feet laterally with all three wheels on the runway. The speed is established with the remaining engine at the takeoff thrust setting, the aircraft loaded at the most unfavorable weight and center of gravity, and the aircraft trimmed for takeoff without exceeding 180 pounds of rudder control force by the pilot with the rudder boost system operating. Conditions of crosswind and RCR may increase VMCG. So what does this mean to us in our takeoff planning in relation to S1, our go, no-go decision speed? Well, I want to be committed to the takeoff, if I have to be, at or above my ground minimum control speed. Why? Well, per our definition, ground minimum control speed is a speed at which I should be able to control my aircraft using primary aerodynamic controls. I'll be able to maintain runway centerline, keep the aircraft safely on the runway, and continue to my rotation speed. So if any malfunction were to happen after VMCG, and I've chosen VMCG as my go, no-go decision point, I should be able to maintain control of my aircraft on the runway surface. Let's think about it vice versa, or in another sense. Let's say S1 is before VMCG. Let's say S1 is over here, some speed less than 88 knots. Well, what does that do for me? I'm committed to the takeoff at S1. Let's say I have a malfunction that's pretty bad, like an engine failure. Let's say I lost my engine after S1, so I'm committed to the takeoff, but I've not yet reached my ground minimum control speed. How are we going to control the takeoff? Well, let's talk about it. We discussed earlier, if an abort is required, we need to use idle throttles, brakes, and speed brakes. However, we just said I'm committed to the takeoff, so that leaves me with no choice but to continue using my rudder, spoilers, and elevator. However, discussing the definition of VMCG, I'm not going to be able to maintain aircraft control. I don't have enough airflow over my spoilers, rudder, and elevator to keep the aircraft within 25 feet of runway centerline. I will actually depart the runway surface, either left or right, pending on the engine failure. So in this case, VMCG has to be less than, I don't know what happened there, has to be less than or equal to our commitment to takeoff. Why? Because if I'm going to be committed to the takeoff, I want to ensure that I have aerodynamic control of my aircraft. I want to be able to I want to ensure that my aircraft is going to stay on runway centerline safely. So in that case, VMCG must be less than or equal to S1. And in the next video, we're going to discuss critical engine failure speed, the last variable of the equation.